So let's do sample exercise 20.4. We're going to look at describing a voltaic cell. We have here, they want you to indicate the reaction at the anode, the cathode, the direction of the electrons, and the direction of the ions. That's in the salt bridge, and the sign of the electrode. So what I'm going to do is draw my two beakers. I'm going to go ahead and put a piece of metal in each one, not specifying exactly what it is. An aqueous solution here. Aqueous solutions here. Then I'm going to go ahead and make my electrons go to the right. And that, I know you can make it go to the left, but I like making it go to the right, so it's easier. Okay, so electrons always flow from the A anode to the cathode, A to C, okay? So now I'm going to look at my chemicals. What do I have here? Over here, you need something that will give away electrons, okay? Something that gives away the electrons, and on this beaker, in this beaker you want something that takes the electrons. Okay, so let's look at our chemicals. We need something that gives away electrons. So Cr2O7 minus 2. Okay. I need to know the charge. So Cr plus 2, I need the oxidation state. So this is -2, oxygen is -2 each. There's 7 of them, total of -14. This has to be +12. The reason I chose +12 is because total, when you add these two, it has to be -12, right? So, but there are 2 of them. So each Cr must be +6 each. Okay, so Cr came from +6, and on this side it became +3. So let me write that down somewhere. Cr used to be +6, and now it became +3. It must have taken in electrons, right? So this one took in 3 electrons to become that. So I'm going to put this, something that takes electrons, I'm going to make Cr +6. And the way Cr +6 occurs is Cr2O7. Okay? Took in 3 electrons, and it became 2 Cr +3. And it actually took in, there's 2 of them. So this is 2, so it took in 2 each, so 6 electrons. Okay, you don't really have to write the equation, I just want to show you that Cr took the electrons. Okay, so that means this is the reaction occurring at the cathode, right? So I'm going to balance this a bit. You have some oxygens there, so I'm going to need some water to balance the oxygen, 7 waters. And I'm also going to need some H pluses on this side to balance the H's, 14 H pluses. So that's what's happening in the cathode. Okay. So what's happening here? Something that's giving away electrons. We'll call that a different color, maybe red. So I used to be -1, and I is now, the oxidation state is 0. Okay, because there's no number there, so we can assume 0. So 6I used to have all its electrons. Now it doesn't have any electrons, right? Because 0. So that means that I minus must have given away some electrons, 6 of them. Okay. So I minus must be in here somewhere, okay? So this is the reaction happening at the cathode. So the I minus gives away 6 electrons, the Cr2O7 takes in the 6 electrons. Okay, so we figured that out. We got the anode, we got the cathode, we got the electron migrations going to the right from the anode to the cathode, the ion migration, and the signs of the electrodes. Okay, so the ion migration has to be this way. So I'm going to draw the salt bridge. Of course, you have to. Okay, so a 6I minus turns into 3I20. You are losing negative charge. So over here, you are losing negative charge, aren't you? Which means it's becoming more positive. Becoming more positive. So if you had a salt, you're going to make the negative ions go this way. And let's say the negative ion is nitrate, for example. You're going to make the nitrates come out this way as 6I minus goes away. Okay, so let's go over here. Here you have so there are a couple ways of thinking about what's happening in this beaker. Okay, so the first one is it's taking in electrons. If it's taking in electrons, it's becoming more negative, right? Negative, right? Another way you can think about it is you can add up the charges. You have here, it used to be plus 14, plus 12, become plus 6. 2 plus 3 is plus 6. That because becoming more negative, plus 12 to plus 6, because it took in electrons, obviously. So it's becoming more negative. If it's becoming more negative, you need, let's say your salt bridge has K plus in it. You need to make the K pluses go to the right. As it becomes more negative, the K plus will neutralize it. Okay, so you have the ion migration. The ion migration, the nitrates, the negative ion go to the anode, and the positive ions from the salt bridge goes to the cathode. The signs of the electrodes. Okay, the signs would be, this is electrons are negative and they're flowing to something that is positive.